Thank you for joining today evening. And my name is Govansh Murat Paitakov. And this year with Momentum Learning, we are offering bootcamp for the US National Chemistry Olympiad. So I have a doctorate degree in computational chemistry. Currently, I am teaching in one of the high schools in Houston area. And I am certified chemistry, physics, math, and engineering teacher. So back in 2006 and 2010, I prepared, mentored, coached my home country's chemistry Olympiad team. And we went to international Olympiads as well. And my students got different various bronze, silver, gold medals in international chemistry Olympiads. So I am familiar with this topic. This year, I'm collaborating with Momentum Learning. And I'm ready to help your kids and students. So what is National Chemistry Olympiad? Each country can send only 4 students, but there is a local chemistry Olympiad competitions as well. So it starts with the local one. High schools register their students to local coordinator, and then students take the exam. Local exam is the first exam. Second one is national chemistry. That is US-wide, and then only very few students from local competitions advance to national one. That is 1,000 students. We are a big country, that's why 1,000 students, we might have local competitions taking place. Therefore, it's very competitive. And from that, so first one is a local chemistry Olympiad competition that is happening in March, and in April, the National Chemistry Olympiad is taking place. Among those 1,000 students taking the National Chemistry Olympiad exam, only top 20 will be eligible for the study camp. And among those 20, only 4. So it's not how big the country is, what's the population. Even China can only have 4 students eligible representing their country in the International Chemistry Olympiad. So as I said, registration has already started, but it closes in January 19th. Sometimes it might be earlier than that as well. In March, they are taking local exam. In April, they are taking national exam and study camp. During the summer, 20 students only, and then 4 will be selected for the International Chemistry Olympiad. So how to register? A registration process. Usually high school chemistry teachers can register their school students. For my school, I'm registering it for maybe 4 or 5 years. So this is the contact person for the greater Houston area. And if your high school teacher knows about that, that's fine. If not, you can share that information, and high school teacher can contact and list of the students who are interested to take the local exam. He can give the list of them, and then that's how registration process goes. It is free. It used to be a $1 entrance fee before, but it is this year. He told me that it's completely free to take the exam. So there is 2 ways you can, the teacher can administer the test. Either teacher can send the students to UOH, where this person, Jerry Yang, the coordinator for the greater Houston area, he works at the University of Houston, and he's giving the test there. So either the students can go to take the UOH to take the test, or if teacher decides, so if there is a lot of students, teacher can proctor it in their school as well. So that's the second way of doing that. What if your school does not participate and the teacher over there is reluctant to register the student? Then as a parent, you can contact this person, coordinator, and then he might suggest some ways of registration for the Olympiad. I think this year they put on the website, so this is new. This year they put students can directly register. And when I asked him about that, he said that although it is that way, they can register over there, he prefers the teachers to contact them. But if the teacher is reluctant, yes, he will find a solution. So we already talked about this local exam. So what we are doing right now is our camp will prepare them for the local exam. We are focusing on local because if you don't pass the local exam or select it, if you don't advance to the national, then what's the point of working hard for the national? So this year, it's kind of, we start late. So that's why we are focusing on local. And if students advance to the national, then we can have accelerated lessons later on. Study camp, that is completely out of our control. What I mean, if selected those 20 students, they will go to one of the universities they select, and everything will be paid, transportation and everything, and university professors will be helping them to study, prepare for the International Chemistry Olympiad. And then 4 of them will be going to the international. There are some requirements to be eligible for the national exam, so not a local exam. Local exam, everyone can take. That's fine. National exam, the student needs to be a US citizen or permanent resident. Students needs to be high school students. They should not be graduating earlier than that year's 1st of May. The age limit is also there, 20, under 20, before the 1st July of that competition year. From local exam to national exam, so each school can nominate maximum 2 students. That's good. If you are the only one who is attending from your school, more chance you have to advance to the national exam. There is a minimum point requirement as well you need to earn to be eligible for the national exam as well, but that is no more than 2 students can attend from specific school. If student has attended previously, so I think then went to the summer camp, they are eligible to the national exam. They don't have to even enter to the local exam. Once you earn for your country the gold medal, actually this is the US policy, not the other, then they can attend to the International Chemistry Olympiad next year. All right, so more details about that is if student is attending multiple chemistry Olympiad study camps, so they can't attend. So if you are eligible for physics and math and chemistry, let's say, you have to pick one. You can't do all of them. And usually the chemistry, the international Olympiads are happening at the same time, so you can't be present at the same time in both places. So that's why. And again, when you go there, very strict. You can't see your student until the testing is done and so on. So as a mentor, that was my experience. So 1 Olympiad per year only. Okay, non-programmable calculators. So basic calculators you can use during the test in the local and the national and the international as well. Non-programmable calculators. All right, so topics. What topics are included there? These are the topics included on the local exam, but for national exam, we will talk about in a bit. It's more, so students need to be knowing all these topics. Organic biochemistry. So even AP chemistry is not dealing with a lot with the organic and biochemistry, but National Chemistry Olympiad, yes, you have to know some topics about that. So basically, most of them are up to here, organic chemistry, they are taught in AP chemistry. When is the good time? I will ask that, answer that question later on. But if students start in 9th grade, that will be the best. So they need to take the test and see it, even if their first year, for the next year, it will be a practice. All right, so the test was, the local one is 110 minutes and 60 multiple choice questions. So each one of these topics, we have a 1, 2, 3, 4, 5, 7, 8, 9, 10. So each unit has a 6 test questions, multiple choice questions. That is always like that. So they need to master all of these, and from each unit, they will have 6 questions in the local exam. National exam is a bit, format is different. It has 3 parts and multiple choice, and then the response part, written part is there as well. And then the third part is a lab skills. That's why this is more complicated. And that one, school cannot administer this national exam, only they need to go to U of H or whatever university they have assigned here. All right, so top 20 students. So there are high honor and honor. So students are getting a monetary prize for that one as well, if they achieve honors or high honor, even if they are not in top 20. So top 20 is selected is going to the 2 weeks camp. That's somewhere. Statistically, about 16,000 students are taking local exams, US-wide, and only 1,000 of them eligible for national exam. So 1 in 16. That's competitive, but not that competitive compared to the 20. All right, so what is a minimum requirement? If student has background of pre-AP chemistry or AP chemistry, so some schools have an honors chemistry, even a regular chemistry, it doesn't matter. If they have some chemistry background, then it will be much easier. It is hard to teach. We have scheduled maybe about 20 hours. So it's really hard to teach all those topics in 20. But if they have some background, already have background, some background, with some quick review, we can do that. We can. So this is a requirement, is some chemistry background is needed. All right. So textbook wise, it's flexible. Any textbook should be working, should work, especially if it's AP or the college level textbooks. That's better. Math is important because a lot of math we are doing. So that's why usually for AP as well, there is a pre-calculus or at least algebra is minimum requirement. They should have a strong math background. So it's not must, but some chemistry background is preferable. Okay, so we have some sample questions here. What it looks like, multiple choice, as we said, but it looks like simple, but it's not actually. So they need to, some of them are very tricky as well. So we will solve some practice questions or the release test questions to get today as well as a sample. So periodic table we will need, so that's why I put it here. So let's do some practice. So if they have background, so I will quickly review them before the lesson. So mole concept, they need to know. The definition of mole is 1 mole is anything that has a 1 mole of substance or particles, that is this many. Avogadro's number, 6.02 times 10 to the power of 23. So if I have a 6.02 times 10 to the power of 23 apples, then I will have a 1 mole of apple, that means. So it's very equality that we need to know, like 1 dozen is equal to 12 pieces. Once we have those equalities, we can do some math conversions from number of particles to a mole or mole to a particle. So if I have this, let me see why it's not. Okay, annotation is silent. So if we have this equality, then we can do two things. 1 mole is equal to Avogadro's numbers of particles. I can convert from a particle, if the particle number is given, to a mole. Quickly, let's say I have what we mean by particle is it can be an atom. Particle can be an atom, and particle can be a molecule, or particle can be a formula unit as well. Formula unit. So what we mean by them is atom is, if I give an example, gold atoms. A molecule can be a water. Okay, water is a molecule. And then formula unit can be a table salt, sodium chloride. These are particle, so repeating units, smallest repeating units. Let's do an example. If I have 1,000, let's say, 1,000 gold atoms, I want to convert it to a mole. Then I can do this conversion, use this conversion factor. Where I get this conversion factor? From this equality. This equality gives me a conversion factor from mole to a particle, particle to a mole. Whatever is, I start with atoms, then I have, I can, instead of particles, I can put atoms of gold. Then I can convert it to a mole of gold. So atoms and atoms should cancel out as a unit, gold atoms. Then you should be getting a, this is what, 1,000 divided by. So if you are entering them into a calculator, you have to make sure that you are using a parentheses. Otherwise, your calculator will do divide it by 6.02, and then everything, it will multiply by 10 to the power of 23, and you will get a positive exponent, but you should be getting negative exponent here. So it is what, 6.02 times 10 to the power of 23. You have to put it in parentheses when you enter it to the calculator. Then you will be getting your moles of gold atom. If you start with a mole, so what we are doing is just flipping these to convert from mole to a particle. This one was from particle to a mole. Let's say 2.3 moles of water molecules I have, and I want to convert it to particles, molecules. So this time water is a molecule. 1 mole of water has this many molecules of water we have. Then moles of water will be canceling out. So conversion factors are the best. If you get used to that, you might think, hey, this is too much work, but why I'm doing this? It also helps you to understand if you are doing it correctly or not. But if you were, instead of multiplying, dividing it by mistake, then what? You will have a moles will be on the top, moles squared divided by molecules. So the units are not canceling out. That means you are doing something wrong. So to have an idea if you are doing it correctly or not, that's the. So 2.3 times 6.02 times 10 to the power of 23 molecules you will get as an answer. Molecules of water. Okay, so this is kind of introductory to mole, and let's move on to the next slide. Okay, so in addition to a mole, we need to introduce a molar mass concept as well. By the way, where we get the molar mass for elements, that is from periodic table. And on a periodic table, if you see the number that is not a whole number, but a decimal number, that's an atomic mass. That is an atomic mass. So atomic mass, it is average atomic mass actually, average atomic mass. And those average atomic mass, if it's a single, let's say one lithium atom, it will have a 6.1 lithium atom's mass is 6.941 atomic mass unit, we will call. But if it's a 1 mole of lithium, let's say, then it will have be equal to 6.941, exactly like this, but it is in grams. This is a 1 mole's mass. That is a molar mass. Molar mass, we call it. And molar mass of a lithium will be, that is 6.941 grams per mole. This is the unit for molar mass. So what I want to show you here is where we find the molar mass of a lithium. Where we find the molar mass for each element is from periodic table. And that is this decimal number. And that is equivalent to 1 mole's mass. 1 mole of lithium is 6.941 grams. This is the equality. If I have equality, like we did for the particles to a mole, mole to a particle conversion, we can convert from mass to a mole, mole to a mass conversions we can do. What if we don't have a element or atom, but we have a molecule like this? Then we will use this, we will get the molar mass of each element and we will multiply it with the subscript. We have 2 hydrogen, 2 moles of hydrogen, 1 mole of oxygen, and then add them up. Multiply with the subscript and then add them up, we will do to get the molar mass of a compound. All right, so let's move on quickly to calculate the molar mass of a compound. We did this part, okay. So usually, sometimes they give the molar masses to you. You don't have to go to a, for simplicity, I rounded them. So carbon is 12, oxygen is 16, where I'm getting this from the periodic table. So 12 grams per mole, 16 grams per mole. To calculate the molar mass, I am multiplying the subscript with the molar mass and then adding them up. So 1 times the molar mass of a carbon, which is 12, plus 2 times the molar mass of oxygen, that's the 16. And I do the math, 44 grams per mole. That's the molar mass of carbon dioxide. If I know this molar mass, then I can write 2 conversion factors. First one is from mole to a mass. Next one will be from mass to a mole conversion. And how we did before, we can convert it. So let's say if I have given a 1.5 moles of carbon dioxide and I want to convert it to a mass, then what? This units will cancel out and I will get them grams, in grams, the unit mass. If I have given a mass, let's say 5 grams, 5.0 grams of carbon dioxide, let's say, then what? I can convert it to a mole. So mole to mass, mass to mole conversions. Okay, with this background knowledge and stoichiometry as well. So as I said, these three things are minimum requirement to solve the next question. That's why I am quickly reviewing this. You need to be able to balance chemical equations. After balancing chemical equation, you can set up the stoichiometry or ratio. So let's do that. How we balance the chemical equation? On both sides, number of atoms should be equal. And you can only, the rule for the balancing is you can only change the coefficients. And coefficients are written in the front of the element or compound formula. So I can put numbers here to make them equal. So I will start with putting 1 for the most complex one. 1 times 2 is 2 carbons I have. I have to make it 2 on the other side. 2 times hidden 1 here. 2 carbons. Carbons are equal. 1 times 6 is 6 hydrogens. To make the hydrogens equal, I need to put 3 here. 3 times 2 is a 6. And once I have all the coefficients on one side, I know exactly all the number of atoms on that side. I already made carbon and hydrogen equal. Last thing remaining is oxygen. 2 times 2 is 4 oxygen, plus 3 times 1 is 3 oxygen. And to make, so 7 oxygens I have on the other side. To make it 7 over 2 coefficient I need to put. 7 over 2 times 2 is 7. So this is a balanced chemical equation. Then I can set up stoichiometry. So this coefficient ratios are giving me a mole ratio. 1 mole of C2H6 reacts with 7 over 2 is a 3.5 moles of what? Oxygen. This is this ratio, mole ratio. Once we have that knowledge, then we can attempt next question. That is showing up one of the newest tests, local tests. 1 gram sample of which compound will produce the greatest amount of carbon dioxide after complete combustion with excess oxygen? So we are burning with oxygen. I don't know which one it is. I just generalized this A and B. And once I balance this, I know I don't need to balance everything right now for this question, but I need to get how much carbon dioxide is produced if I burn 1 mole of that substance, whatever it is. So this carbon subscript will come here as a coefficient here. 1 times A is equal to 8 times 1, whatever that number is. So that's I need to keep in mind. Then I will start with the mass of that compound. And I will convert mass to a mole by using molar mass conversion. Whatever the molar mass, I need to divide it. 1 mole is a numerator. I need to divide by molar mass. This grams in 1 mole, that's the molar mass of that compound. And then I need to multiply that with the A moles, whatever the coefficient here. So 1 mole of this compound will produce A moles of that one. So here I converted it to a mole and then 8 times. So that's why A moles is a 1 mole. So by the way, when you do this correctly, everything should be canceling out to check your answer. 1 mole will cancel out with this 1 mole, and 1 gram times A moles divided by molar mass of that compound. You should be getting the mole ratios, mole of each compound that is producing, if you do the math. This is a long way of doing this. So you are doing that. So 1 gram divided by molar mass is 16. I calculated it here. For this one, it is a 42. Because this is 1, I need to multiply it by 1. But this one, I need to multiply it by 3. So you have an idea. You can do it long way, but that's a waste of time. You have a 60 questions and 110 minutes. Some questions are easy, some questions are taking longer, but you are competing against the time as well when you are competing on the National Olympiad. So you need to come up with, so you need to do solve so many questions, and it should be you should be able to, thinking process should be very quick, and whenever is possible, I don't have to write it. So right now I'm trying to show you, that's why I'm going into details. But for the multiple choice part, you don't have to even show your work. Therefore, how fast you solve it, that is your advantage. So once actually you do this, these two only, you need to figure out that, okay, actually there is this 1:4 ratio, 3:6 ratio. I am multiplying by this and timing those. Once those ratio is 1:2 ratio, this is 1:4 ratio. 1:4 ratio produce this many moles, 1:2 ratio this many. Once the ratio increases, hydrogen to carbon ratio increases, it's getting lower. Then it is what? 1:4, 1:2. This is 1:2 point something. This is 1:2 point something. So the higher the hydrogen ratio, then it should be getting lower. If you have that pattern, if you can read that pattern, you can easily, without doing these two calculations, you should be able to get the answer here. As I said, it is not only knowledge that you need to know, but you are competing against time. So how quickly you can solve the problem, that helps you a lot. All right, so let's move on to the next question, sample question. For this one, the average atomic mass and percentages. So they are making it complicated, or students are getting kind of, why? I can calculate the mass percentages easily, but they are asking a mole percent. They are asking a mole percent. So, but with enough practice, you should know that mole percentage will be equal to a mass percentage. So if that is only true, if you're whatever you are comparing, their molar mass are very close. Here they are isotopes of one another, and 187 to 185 molar mass are very close. Therefore, you will be getting a mole percentage is equal to a mass percentage. That's one thing. Later on, I will decide. But how to calculate the mass percentage? If you have two isotopes, their percentage should add up to 100. And I need to quickly set up that if I give X for one of those percentages, I need to set the, instead of Y, I need to set it 100 minus X. Then once I solve for X, I'll be getting the percentage. So by the way, all percentages should add up to 100, and molar mass of first isotope times percentage of first isotope plus molar mass of second isotope times mass percentage of second isotope. So whatever, how many isotopes you have, you should add them up, and that should be equal to, if you divide everything by 100 on that side, you should be getting average atomic mass for that element. This is the formula equation that you need to use. So I quickly set up that percentage times the molar mass plus percentage, actually I distributed it, percentage here times the molar mass and divide by 100 should be equal to average atomic mass they already provided to us. So once you have that, you solve for X, and then you got a 40 for the 40 is for X, and that's for 185. And they're asking for 185. You have to be extra cautious. You might be, if you have set up X 100 minus X for this one, then once you solve for X, that is the percentage of this one, then you have to subtract it from 100. So you have to be careful over there. And then, as I said, mole is a mass over molar mass. Because the molar mass are comparable to their mass percentage will be equal to a mole percentage, very close. So that's why the answer will be A for this question. All right, so as I said, when I am teaching these, I am expecting students have some background. So if I am teaching entirely each and every topic concept here, then we won't have time. If we don't have extra hours, then we will not have time to cover everything. So that's why each lesson, 2-hour lessons on the bootcamp as well, it's approximately one topic. That's why students should have some background. All right, so let's move on to the next one, next type of question. Okay, here, this is another topic, loose structures and hybridization. So let's go over with the topic itself, and then we will attempt the question. So here we have a valence electron concept we need to. So carbon is 4, hydrogen is 1, oxygen is 6. They won't be given to you. How you will figure out if it is a carbon has a 4 valence electrons. So that's why I put that periodic table here. So how we figure out the valence electrons. 1A group has a 1 valence electron. 2A group has a 2 valence electron. And B block, we skip that. We don't count valence electrons for the B block. But 3A will have a 3 valence electrons. 4A will have a 4, and maximum you have is 8. So carbon is 4A, that's why it will have a 4 valence electrons. Hydrogen will have only 1 because it is 1A group. And nitrogen will have 5, and oxygen will have 6. So these are the ones that we need for now, for the question. So let's see. If I have that, I can quickly go back to the. So carbon has 4, hydrogen has 1, oxygen has 6. That's where we found the valence electrons. And once you have that valence electrons, you count them. For this one, for example, let's count them. Total number of valence electrons should be the same after the drawing. So before you start carbon atom, we have one of them, or no, 1 carbon and another carbon. Here's 2 carbon, 2 times 4 plus, so 8 valence electrons. How many hydrogens we have? 1, 2, 3, 4 hydrogens. 4 times 1 plus, because each hydrogen has 1 valence electron. And oxygen, we have 2 of them, 2 times 6. So total valence electrons I should have is 8, 12 plus 12, that is 24 valence electrons I need to show up on my drawing. So this is a drawn one, but how we get to this point, I will show you. And we have given this condensed formula, not a structural formula like here. So from condensed formula, we need to figure out this structural formula. How? Carbon, we need to also go over these requirements, minimum requirements, or the rules. least electronegative atom, you have to put it at the center, but this is a very big one, so I had to think about that. Oxygens cannot be at the center, so carbons should be at the center. We need to start connecting with one bond, so at least there should be a one bond connection if you have two atoms are connected to one another. Hydrogen can make only one bond because it can, hydrogen has one valence electron. Once it is sharing, another element shares with one electron, that's it, it is complete. Octet rule, so that's the octet rule. It is complete, so you can't put more. So that's why two bonds are equal to those two bonded electrons are equal to one bond. No more bonding. So that's why if it's a central atom, it should be able to do more bonds, but hydrogen cannot make those bonds. That's why it should be always on the edges. All right, so this one we will talk about when we talk about hybridization. So let's continue that. Condensed formula giving me some hints. Hey, this carbon has 3 hydrogens attached to it, it says. Carbon, those hydrogens needs to be attached to this carbon. And then this carbon is attached to another carbon. And these oxygens, I don't know, without looking at this, I don't know how it is, but I can try oxygens this way, but I need to figure out that it's not working. So COOH is actually acid formula, carboxylic acid, organic acid. So students should have a background of oxygen is here, that one of the oxygen is there, and another hydrogen is attached to that. But I don't know how to put these things yet. So how I can do? At least they need to be bonding with single bond. 1, 2, 3. And each single bond is a 2 electrons. So far I have used 6 electrons out of 24 valence electrons. They need to match. I can check my work if I'm doing it correct or not by calculating afterwards how many electrons I put there. So I need to be showing total 24. And these 2 carbons should be also bonded with at least single bond. And this oxygen needs to be connected to carbon with 1 bond. This oxygen needs to be connected to carbon with single bond. And this hydrogen needs to be connected to single bond. So I have connected all of them. Now I need to count how many electrons I have used so far. So 1, 2, 3, 4, 5, 6, 7. 7 times 2, each of them are 2 electrons. So 14 I have used. I had to put 24 minus 14, 10 more electrons I need to put. Where I will put? So there is this octet rule, octets, CONF. They are strictly following, these elements are strictly following octet rule. So carbon, octet is octa 8 electrons. So if carbon has 8 electrons, that's it. I cannot put more electrons on this carbon, that means. 1, 2, 3, 4 electrons, therefore 4 bonds, therefore 8 electrons. This carbon has already octet. But this carbon has no octet, 6 electrons. This oxygen has no octet. So I can put these 2 here, and then I can put here 2 electrons, make it 8. And I can, so how many electrons I have put? 6, and I need to put 10. So 6, 8, and 10. So is it done? No, it's not done, because this carbon is octet, this oxygen is octet. So 2 plus 2, 4, plus 2, 6 plus 2, 8. But how about this oxygen? 4, 2 plus 2 is 4, plus 2, 6. So this is not octet. I had to make it octet. How you can increase the number of electrons on an atom without adding electron? When atoms share electron, their electrons, both atoms' electrons become higher or larger. So then something needs to be shared. If this one is shared, then that doesn't make sense. It's not changing on this one, but it will make the carbon's electrons more. Therefore, sharing should be happening with these 2 electrons. So I have to move these 2 electrons to here so that sharing, carbon will still have 4 bonds, 8 electron, and this oxygen will be also happy by increasing its electrons from 6 to 8. Then you will get this structural formula. So what's the time? Okay, I don't want to spend too much time because I want to leave QA questions. So another thing they need to know to answer that question, hybridization. So if each group is, what is each group? If you have a lone pair non-bonding electrons, these are non-bonding electrons, they are counted as one group. If you have a single bond, that is counted as one group. If you have double bond, it's not counted as 2 group, just one group. Triple bond, it doesn't matter. This is also one group. So each one of them are one group. So how I can figure out what's the hybridization on this carbon? I have one group here. So double bond is a one group. This is another group. That's another group. I have 3 groups. Then 3 groups is sp2. 2 group is, so here we are mixing s and p orbitals. 1s, 1p, 1 plus 1 is 2 groups. If you have 3 groups, 1s, 2p, you are mixing, then it is a 3 groups. So sp2. So this one is 3 groups, therefore its hybridization should be sp2. With that knowledge, we should be quickly answer next question. All right, so which one is sp2 hybridized? And it has a one lone pair, it says. So we know hydrogen has 1, nitrogen has 5, carbon has 4. How many valence electrons I have calculated here? So hydrogen has 1 valence electron, nitrogen has 5. 1, 2, 3, 4, and 5 valence electrons. Each hydrogen has 1. So they are making bonds. So this one has 1 lone pair. That's good. This part is good. But is it sp2 hybridized? No, because I have 1 group here, 2, 3, 4 groups. If it's a 4 group, then it says sp3. 1 plus 4, 3 is 4. sp3, not sp2. We are looking for sp2. What about here? 1, this carbon has 4 valence electrons, and this nitrogen has 5 valence electrons, and we need to make at least 1 bond, and we start sharing electrons so that these 2 are shared. We can have an octet. These 2 also share. Carbon has 8 electrons, then 4 bonds times 2, 8 electrons. Nitrogen is also octet. 3 bonds, 6 plus 2 electrons that's not bonded, 8 electrons. So this is good. So do we have a lone pair? Yes, but is it sp2 or sp2? No. Triple bond is considered as one bond, one group. This is another group. So I have 2, which is sp hybridized. So this carbon is sp hybrid. Oh, sorry. I need to focus on carbon. Oh, no, nitrogen, sorry. Nitrogen. So it is 2 groups sp, not sp2. Okay, so I'm running out of time. Let's quickly do this one as well, and then I will stop. So each hydrogen has 1, carbons have 4 valence electrons, nitrogen has 5. So 2, 3, 4. So nitrogen should have 5. Okay, 5. And each hydrogen has 1. This is there. And they are making bonds. They are making bond. So carbon will make bond, and we need to stop there. Carbon has 8. So this 2 stays as a lone pair then. This 2 stays as a lone pair. Is this nitrogen has a lone pair? Yes, one of them. But is this sp2? No, because one group has a lone pair, 2, 3, 4. So we have 4 groups. It is sp3 like here. Then our answer should be this one. All right, so I was planning to solve one more question, but because of the time constraint, I believe we will stop here. This was a very tricky question as well. I think we have time for question and answer, Q&A. Please feel free to ask questions if you have any. Mr. Kai, we couldn't hear you.
Hi.
Hello. Yes.
Hi. Thank you for the presentation. Yeah, it's really, really great. Very helpful. I'm just curious, what's like a study scope of the Olympic chemistry? Like this looks like there are some college chemistry and some organic chemistry. Where to find the syllabus or something like that?
Yeah, syllabus. It has some college level topics there, but what they are asking or what is tested is kind of limited. You don't have to go that deep. In other words, for those organic chemistry is very broad, but they are testing certain parts of it, not everything.
Yeah, I see. Yeah, like the Lewis structure, I think it's really deep, seems like.
Actually, Lewis structures is high school topic.
Oh, it's a high school topic. Okay.
It's a high school. So they are learning in high school. If they took the honors on level or the AP chemistry, on all classes, they are learning that.
Okay. Oh, sorry, I didn't take high school chemistry in the US. Okay, thank you. Is there any book that we can use to prepare this exam?
So I strongly recommend them to look for the questions and then textbook. Any textbook should be fine as long as it is AP level or college level textbook.
Okay.
But even there is a online free textbooks, LibreText. So I believe that is that one. Let me quickly show you that. I believe LibreText. Yeah. This is a free resource that is even enough. Everything is there. They can search inside whatever they are trying to learn. So let's say how we can help you. I want to search for stoichiometry, for example. So they are giving the where it is, practice, and all those stuff is there. So this textbook is also enough.
Okay. Well, and you also said the college textbook. You mean the general chemistry?
General chemistry, yes, but as I said, it's not. The questions are interesting and tricky, but they are not. They are not testing everything that is learned in a college. What I mean, so it is high school chemistry is also okay with some extra stuff, but the level rigor is even harder than the AP chemistry. The types of questions, tricky questions there are, so they need to be very extra cautious about that.
Okay. Yeah. Okay. Yeah. I can see from the examples. Yeah, those are really probably really change for middle or high school students. Okay.
Yeah, and as I said, it requires more and more practice to master those type of questions, because there is no time to think that long. You have to answer them within a time period. So it's not like, even if you master the topic, that does not guarantee that you can solve the problem, because you have to have so many problem solving skills so that once you read the question, you immediately start setting up the equation and then solving it. So there is no, should it be like that or like this? You don't have that time, thinking time.
Okay. Yeah, you got how to very familiar with those. Okay. See. Yeah. Thank you.
You're welcome.